Okay, the following is a video over Algebra 1, Unit 1, Section 3, and this is a section about an introduction to functions. A function is probably one of the most powerful things that we talk about in algebra. This is the fundamentals to computers, all right? This is without functions, without the concept of functions and the definition of functions, we wouldn't have computers, okay? So this leads to computers. Computers! Okay, and I'll talk about that here in a second when we get more into what a function is. But what it wants us to, our objectives today, we want to determine the domain and range, two very important vocab words that we will talk quite a bit about, of a functional relationship giving a mapping diagram, a table, graph, or scenario, okay? So functions, you know, we have these three things. We've got a mapping, a diagram, a table, a graph, or a scenario, okay? We also want to analyze a mapping diagram, table, graph, or scenario to recognize functional relationships, okay? So the first thing we have, this is a mapping, okay? This is a mapping, all right? And they use these words called input and output. Okay, the first thing that I want to tell you guys and show you guys is that an input, these are x values. Okay, outputs are y values. Okay, so those things go hand in hand. If I say the word input, that means an x value. If I say the word output, that means y value. That's probably one of the most important things you can come away with this today. All right, so then we have this thing called the domain, okay? Domain, okay, look what it says. The domain is the set of input values. So above that, I'm going to write the domain set of input values. I'm just going to write x values. Okay, domain means x values, for which the relation is defined. The range is the set of output values. So the range is the set of output values. Those are y values. Okay? So we've got these three things, okay? We've got x values. Okay? Another word for that is input. Okay? Another word for that is the word domain. Okay? And then we have y values. Okay, another word for that is output. And another word for that is range. Okay, so these are important. Okay, all these mean the same thing. Okay, they all mean the same concept, same idea. All right, same thing with your x values, your input, and your domain. These are all the same idea. All right, so let's go ahead and take a look at a mapping. All right, so what we have here is we have these ordered pairs, okay? Again, input, output. So I'm going to say this. These are x values, all right? My input are x values. My output, those are y values, okay? And so what it says here is we just have these ordered pairs, okay? Notice how the x values in each of these ordered pairs shows up down here, okay? -4, -4, 0, 0, 1, 1, 7, 7. And then each of these corresponds with their given y values. So I have the value of 3, 3, 5, 5, 1, 1, -2, -2. Okay, so then it says, okay, what's our domain here? Now, when they ask us for our domain, they kind of have us do this weird thing where I do a bracket, and then I say x, okay, domain, set of x values, this big line, and then we write the number, we just write down the x values that we have. So -4, 0, 1, and 7. So -4, 0, 1, and 7. Okay, this is the set of x values. Just the x values that are there. The range, we do the same thing except for we call them the y values, okay? And those would be 3, 5, 1, and -2. So I'm going to do 3, 5, 1, and -2. okay? And these brackets just mean a group of values, okay? So a set of numbers, all right? All right, let's take a look at the next one. The next one shows, all right, so you have these different values here, and it says from -6 to 0, 2 to 1, -7 to -4, 11 gives us 2, and so does 3, okay? And remember, you know, the input, this is our domain. These are the x values, okay? The output, that's our range. These are y values. All right? So then it says, what is the domain of the relation? So when you hear the word domain, we need to be thinking x values, inputs, okay? So domain, x values. Also another word for that is input, okay? And so if I look over here, it just wants me to list off, okay, what values do we have? So I've got, okay, I've got -7, -7, -6, -6, 2, 2, 11, 11, 3, and 3. So my answer for this is the second one, okay? First of all, when it asks for domain, it wants x values. This is giving me y values, so these don't work, okay? And then, yeah, I just want to figure out which ones are the inputs, which ones are the x values. All right. The next thing I want to do, it says independent variable and dependent variable. Independent variable says it represents the input, okay? So if you have an input, we call those x values, all right? Dependent variable represents the output values. These are often called y values. Okay? So let's take a look at this question, okay? It says that Isaac takes a 216-mile trip from Boston to New York City. He drives at a rate of 54 miles per hour. The equation d is equal to 54t models his distance over time t in hours. Complete the table of values and identify the independent and dependent variables. So they give us this equation here. Okay, they give us this equation that d is equal to 54t. So I'm going to write that down here. D is equal to 54t. Now, if I wanted to write that using x and y values, I can do that, all right? This is the same thing as me saying y is equal to 54x, okay? So it's typically what you guys will see, you know, is an equation that doesn't have x and y, but your ability to go, hey, wait a second, this equation means the same thing as this equation, except for we're dealing with different variables, okay? Now, here's the thing. When you drive in a car, all right, if you're traveling at a constant speed of 54 miles an hour, which is this value right here, then your distance depends on how far you travel or how long you travel for, okay? You know, your distance depends on how long you go. So at those different time values, we can go a certain distance, okay? Now, because we've kind of identified t as x, okay, I know that my independent variable, okay, independent variable is time, okay? And my dependent variable is distance. Now, another way I could tell that is just by looking at this table, okay? Usually what you have is you have x values in the left column, and then you've got y values in the right column, okay? The key to algebra is your ability to understand how, you know, look at a table and identify, okay, these are x values, these are y values, all right? So what we can do is we can fill this out. Now, at time 0, okay, if I plug in 0 into this equation, all right, into d equals 54t, if I plug in 0 for t, I've traveled a distance of 0 miles. After 1 hour, if I plug 1 into this, okay, it's going to give me a value of 54. okay? And how I'm getting this is I'm just going, okay, if I take 54 times 0, okay, this one was 54 times 1. Okay, after 2 hours, 54 times 2, that's going to give me 108 miles. Okay, after 3 hours, if I do 54 times 3, I get 162. Okay, and if I do 54 times 4 hours, then that's going to give me 216. So the question is, well, how long would it take Isaac to drive from Boston to New York? $260-mile trip. We traveled 216 miles in 4 hours. Okay? So this is a standard function. Okay? All right, let's take a look at the next one. Okay, it says the cost to rent a moving truck. Let me get this on the same thing. Okay, the cost to rent a moving truck is a flat fee of $25 plus 60 cents per mile. The equation C equals 25 plus 0.6 m models the cost C in dollars for the number of miles m traveled in the truck. So all it wants us to do is to identify the independent variable and the dependent variable. All right, so let's recap real quick. Let's think about independent variable. That means x value, right? Dependent variable means y value. Now, it's kind of hard when you have this equation, C is equal to 25 plus 0.6 m, okay? Now, what I would normally do, guys, you have to think about this, okay? The cost depends on what? The cost of this truck depends on the miles that you travel, right? The more miles you travel, the more the cost is going to be, right? So one way to think about that is go, okay, which one depends on what? The cost depends on the miles that you travel. If you travel a certain number of miles, it affects your cost. So, that's what I see here, okay? So I would put the cost, C, is your dependent variable, okay? Your independent variable, the one that can change, the one that you choose to, however far you need to travel, in this case, is your miles in m, okay? And you can almost always think about it like this. If you have an equation like this, where you have one variable is equal to something else, well, change that variable to a y is equal to 25 plus 0.6x, okay? They mean the same thing, all right? They're not the same thing. They're different variables, but the idea is the same. You'll have the same graph. You'll have the same, table of values, It just kind of depends how you look at it. But your ability to go from one equation to the other, to recognize that this is the same thing, just different variables, is crucial in algebra. All right, that's the biggest jump you guys are going to have to make. Okay, let's take a look at these next two problems. Now, before I do anything, I want you guys to write the word function at the very top of the page. Okay, function. Okay, and I'm going to talk about this again and again. I forgot to mention it on the last page. But a function is where, no, hold on. Function is for every x value, okay, there is exactly one y value, okay? And we'll talk more about that, towards, as we continue our work on functions. Okay. Now here, okay, on this one it says the altitude of a plane A over time t is shown in the graph below, okay? Identify the domain and range, okay? So it wants us to say, okay, so if we identify the domain, what does that mean? What are we trying to find? What does domain mean? Your x values, okay? So domain, these are your x values. All right? So if I look over here, okay, this is like an x-axis. This is like your y-axis, all right? Where do I have x values? They start at 0, right? And they stop at 90. So what we would do to show what our domain is we would do this thing with the brackets, and we would put in x. Say, okay, we're dealing with x. Actually, no, not x. Our value that we have is actually t. Do need to use the correct variable. So we're dealing with t. That's our domain. And the values go between 0 and 90. Okay, I'm just going, okay, domain. What's my domain? I ask the question, and I'm going to write this out here. I'm going to say, the question I ask is, where do I have x values? What are all of the x values? Okay? And that means that, we have all these points between 0 and 90. So what I would say is that we go from 0 is less than or equal to t is less than or equal to 90. All right? So when it asks, what's our domain? I go, okay, where do I have y values? Or I'm sorry, x values. I have x values that go from 0 all the way to 90. So to show all those values, I have to use an inequality. I have to say, okay, between 0 and 90, that's where my x values are. Okay, in this case, they're values for t, which are time. Another question is, how long was the flight? 90 minutes. It took us 90 minutes to travel whatever distance. Okay? That's how long the flight was. It's just a bunch of different ways of saying the same thing. Okay? Now it says, okay, well, what's the range? All right, so what's my range? Again, a range means what kind of values? Y values. Excellent. All right, so then I ask myself the question, okay, for range, where do I have y values? Okay, and that's just the question I ask myself. So then I come over here, and the variable that we're using here is a. So I'm going to put my bracket down. I'm going to label what variable we're using, okay? And when we're on the ground, they start at what, 0 feet? And then they reached a maximum altitude of 21,000 feet? So you're saying, okay, where do I have y values? Where did we start? Where did we end? Okay, how far do we go up? So I'm going to say this. We start at 0 is less than or equal to a is less than or equal to 21,000. If you can read that. Okay. This takes a little bit of practice, but this is a very, very, you're going to be asked this question quite a bit. Okay. All right, let's take a look at the next one. Our friend Leon, my grandma, she would always sit there. She would always tell me that whenever they would do the Christmas play in her school, she went to a Catholic school, and she would, and she's from Chicago, they would have the sign that says Noel. But then she said for every year these kids would always switch it up. So instead of their shirt saying Noel, it would say Leon. Okay, so my friend Leon throws a ball off a cliff, okay? The graph over here represents the relation that models the ball's height, age, in feet over time. Do you guys remember how we did that graph where I showed the ball being thrown up in the air and it falls to the ground? Same thing, okay? The only difference is that we have to think about, what's the height of the ball at time 0? The height of the ball at time 0 starts at 48. Okay? So then it says, what is the domain? Okay? Domain. So I'm going to ask if it asks me what's the domain, I'm going to then ask, where are the y values? Or I'm sorry, where are the x values? Okay? So if it asks me that, I go, okay, I start here at 0, right? That's where my x values start. Where do they end? They end at 3. Okay, and my variable that we're using is t for x. All right, that's our independent variable. That's our x value. So between 0 and 3, boom shakalaka. That's what we're dealing with. Having fun yet?
Yeah.
Good. All right. Yeah, it should be easy. Trying to make it easy. Okay. Okay, Teresa stated that the heights of her students in her class were not a function of their ages. Which reasoning could justify Teresa's statement? So it says that the heights were not a function of their ages. Okay. And remember what we said. Okay. For every x value, there is exactly one y value. So the question is, Teresa stated that and this is kind of a weird question, but she says the heights of the students were not a function of their ages. Okay? Can two students have the same height and have different ages? Wait, okay, let's read through these. Two students are the same age but have different heights. Okay. Two students have the same height but could have different ages. This is the true one. And we'll kind of elaborate on that here down below. Okay? Because we want to say, okay, what is a function? What isn't a function? Okay? And that's back to what we said up top. It says, does each element in the domain correspond to exactly one element in the range? Basically what they're saying is, does each, and let's just rewrite this and say, does each x value correspond to exactly one y value? Okay, remember domain is your x, range is your y. Domain is your x, range is with your y. So what we know here is that, if your x value is -5, you get 2. 2, if your x value is 2, your y value is -8. Okay? If your x value is -1, you get -8. That's okay. Okay? We just want to know that 5 goes to one number, 2 goes to one number, -1 goes to one number. Now over here, what you notice is that 3, okay, is your x value, you get 4. But then all of a sudden you say 3 is also -5. This part right here, okay, is what makes it not a function. Not a function. All right? Every x value only goes to one y value. Okay, and I'll talk more about that later. But that's how we have to look at it. All right? Okay, then it says determine if the set of ordered pairs represents a function. So what I'm going to do is I'm going to write down the x values. Okay, so I've got 3 is my first x value. -8 is my second x value. 5 is my third y value, or x value. 4, and then 9. Okay? And then I'm going to write out my y values. So I've got 5, I've got 0, I've got -2, I've got 4, and I've got -1. Now the question is, 3 only goes to 5, right? 8 corresponds with 0. 5 corresponds with -2, 4 corresponds with 4, 9 corresponds to -1. So if I can say that all of my x values only go to one y value, then yes, this is a function. Yes, this is a function. Notice the root word of function is fun. We're having it. Understand? No. All right, this next question on the next page says, which represents a function? I just want to make sure that every x value corresponds with only one y value. So what I see here is that every x value is different, okay? And we just get one value for each y value that's represented. So this is a function, okay? All right, the problem here on this next one is that -2 corresponds with both 10 and -7. No, not a function. Okay, let's take a look at the next one. What I notice is that I have two of the same x values here, 6 and 6, and I get different y values. No, no, not a function. Okay. Okay, we also have what's called the vertical line test. Okay, and the question is can you draw a vertical line, all right, that goes from, if you go from left to right using this vertical line, it should only hit the graph at one point each time. Okay, this is a function. If I draw a vertical line, so usually what I do is I take my pencil and I physically put it on the page and I go from left to right. And at every single point along that movement, we should only intersect the graph once. But over here, okay, notice how it intersects the graph twice. That means that we don't have a function, okay? So if you draw this line, you put this line here and you go, all right, well, I have two different y values for one x value. That's not a function, okay? Make sense? Yeah. Okay. So then it says, which graph does not represent a function? So again, let's just take our vertical line. Let me draw another one here. All right. So if I draw this line, if I take this line, come on. Okay, if I go it over this graph here, notice how it just crosses that graph once, right? So this is a function. Any line that you have, except for a vertical line, is a function. Okay, as I move this line over the whole thing, it only touches it once. Uh-oh. Touches it twice. Okay, this one isn't a function. This one is a function. This graph is a function. Okay, but this one ain't no function. We ain't having no fun in here. I'm just kidding. We are having a blast. Right? Right? Okay, see you, bye.